Yes, good afternoon, ladies and gentlemen, and it's my honor to be here today to present about our studies. I am Ngoc-Mai Nguyen, and you can call me Maya. And my presentation is about unveiling building facades, the deterioration, a drawn power deep learning approach for seamless type peeling detection. And here is our content. How to Oh, there, yes, the table of contents. So move to the first part, the introduction. That maybe I wanna ask, have you ever been to Taiwan before? If the answer is yes, maybe you can see that you can found that Taiwan as well as maybe China and many countries in the world have the unique construction style. We have the Thai like a predominantes shielding the whole facades. Like you can see in the picture here, all the buildings here have the Thai outside the facades. So we have a problem like in Taiwan. The average building age is 28 years, and Taipei, the capital of Taiwan, buildings are the average is over 40 years, and then sometimes it's normally you can maybe found now the tide peeling. The widespread tide peeling issues due to weather and also because of earthquake. So like here you can see that there's all the building have all tide outside, and then there's many tide peelings and also of at the high story or low story or inside or something. Yeah. So uh, s- yeah, significant of tide peelings. It really impacts the safety and structural stability, and it threatens the residents with falling accident. And of course, it disrupts the waterproofing and insulation, and also decrease the material qualities. So it is essential for identifying and addressing the tide peeling and in fact, in Taiwan, founding and marking the type peeling is a job, is a very important job, but it done manually by humans. So traditional method is labor intensive, expensive, and also risky for surveyors. So, and beside, currently, we all know that AI is applied into the construction engineering, and by utilizing the computer vision and AI for automating damage assessment. And there's many models like faster RCNN, SSD, and YOLO successfully detect the surface damage like the concrete crash. And then, but in the literature, there is like a focus on advanced deep learning methods for identify the type peeling on building facade. And existing methodologies like practical modification potentially come promising accuracy and also challenge in feature extraction due to the complex image context and drawn access constraints. So in our research, we introduced the YOLO-M. It is a segmentation model tailored for type peeling detection only. We integrate the YOLO version 7 with BlendMask and then augmented by ELAN for blocks for improve the performance and operates within one state framework for pixel-wise segmentation. So please, here is the detail for our methods. Our methods have two parts. The first part, we introduce what is the blend mask-based image segmentation procedures. And then we introduce our YOLO M, the structure. But because of the limited time, I just go very quickly from the 2.1 blend mask-based image segmentation procedures. It is one state instant segmentation with the fully convolutional one-state object detection framework and departure from traditional methods like YOLO and mass-RTNN, notable for its efficiency and accuracy in segmentation tasks. Unique approach avoids anchor boxes and region proposal, leading to swift inference. And architect components, it comprises feature extraction network and mask prediction branch. Feature extraction combines Resnet and FPD And here is our YOLOM. We introduce a network based on ELAN designed to counteract gradient deterioration in larger networks by optimizing gradient length with computer and computational blocks. ELAN is strategically incorporate between downsampling blocks in the backbone, enhancing the feature extraction and facilitating faster training and experimentation. And yes, maybe please just refer to our frameworks. It is the whole framework of our YOLOM. It is a blend mask with ELAN backbone and SPP, ELAN, and then PAN. PAN is the Pyramid Attention Network. Yes, and so it also like a backbone, also like the blend mask framework, like we already have backbone and then bottom module and base and blend module. But it is a whole inside thing is YOLO version 7. Okay, so I move to the data collection. The data we collect by ourselves, we go to we choose the high pedestrian traffic area, including the university campus, apartments, hospitals, government office, and activity centers. And we take many photos about tile peeling in Taipei, New Taipei, Taoyuan, Hsinchu, yeah, cities at the north of Taiwan. So for the low and medium stories, we use the phone and cameras to take the photos. For the high stories, we use a drone. And then a data set of totally 400 surveys image was used, comprising 758 instant appealing types. And we also do the segmentation for the seal area, not only the peeling, also the sealed. So they are the peeling type and also 529 instant of seal types. And then after that, we make so there are 8 locations, and here is the total of image for our data set. And then yeah, the instant for training and test of peeling and seal is like this. So but for the model performance assessments, the metrics, we use AP across varying IOU thresholds of MEP for different object size. And yeah, IP 50 and 8075 for small, medium, and large objects. And here is our computer features. And also the standard image size, it is 640 times multiplied with 340. And batch size of 6 was used during the training over 10,000 iterations. So here is the results. YOLOM is our proposed model, and then we compare with other models, other famous model at that time. And you can see that for YOLOM, we have the they superior to other models, including BlendMask CSP, darknet FPN, and the others for the segmentation results and also for the boundings results also. And here is AP versa for the small and medium and large. So I move on to the conclusion and recommendation. The conclusion, the study introduced the YOLOM, a deep learning-based tool for identifying the type peeling on building exterior, adding proactive maintenance efforts, and incorporates state-of-the-art backbone and neck modules, setting a performance benchmark, a collected and diligently curate dataset containing 400 building facade images with 1,287 instant appealing and sales types confirm the proposed YOLOM effectiveness. Our recommendation, maybe we will focus on the integrating global building visuals to enhance our YOLOM. And also, maybe we will analysis plan to assess the impact of various model components and strategy for future enhancement. So here I put a video for our YOLOM, and the building you can see here, it is, oh, sorry. So maybe, yes, that's
How long is the video?
15 minutes. No, 15 seconds, sorry.